Hello, today we'll be seeing the computer security in this lecture. Here we'll be seeing firstly what is the security problem, the reason for which it arises, then what are the program threats, and the system and network threats. Now the objectives here are to discuss the security threats and attacks, then explain the fundamentals of encryption, what is authentication and hashing. We'll also see what are the uses of cryptography, and we'll also see various countermeasures which can be used to security attacks. So firstly, what is the security problem? Now most of the system here in today's world need to be secure. Generally what happens is the system is secure if the resources are used and accessed as intended under all of the circumstances. But what happens nowadays is this is actually not possible, and it is impractical to assume that such security will be available. So in fact you can say it is unachievable. That is why intruders generally attempt to breach security. Now there are two definitions which or words which seem make might look the same, but there is a difference between how they are or how they are treated from the system point of view. That is threat and attack. Threat is a potential security violation, whereas attack is an attempt to breach the security. Now attacks here can be either accidental or malicious. Now whenever the attacks are accidental, there is a provision or it's easier generally to protect against such attacks because those might be accidental. That is, they are not with the intended purpose. Whereas malicious attacks are generally done with a particular approach in mind. So that is why they want to have a misuse of the system, and that is why it is very difficult to protect against such attacks. Next, we come to the security violation category. So there are various categories under which the security violation is categorized. First one is the breach of confidentiality. So here the erroneous software just tries to unauthorized reading of the data. So it tries to read the data, but which it is not having access to. Then the second category is breach of integrity. Here the malicious software or the malicious attack just tries to get unauthorized access to the data and modifies it, due to which the integrity of the data is lost. Then the next category is breach of availability. So here the software or the attacker tries to get unauthorized access to data and destroy the data. Then the theft of service is the next category. So here this is about getting unauthorized use of the resources and using them for their own benefits. And one of the most popular attacks or violation categories is denial of service or DOS. This just prevents the legitimate program to use the actual whatever resources it can use and it is supposed to use. So prevention of the legitimate use is the denial of service. Next are the various security violation methods. So the violation methods are again classified into many. First one is masquerading. So in this scenario, the attacker pretends to be authorized user to escalate privileges. So the privileges which are present for a program might be different, and the attacker tries to bypass those privileges and escalate those privileges in order to gain much more access to the actual program which they want. Then a replay attack. So this generally happens with message modification. Then the man in the middle attack. This is one more security violation method. So here the intruder just sits in the data flow, masquerading as a sender to the receiver and vice versa. So here the attacker will be sitting in the middle of the sender and the receiver and pretending to be one of them. So the receiver or will be sending the data to the masquerader and not to the actual intended recipient, which is the transmitter. Then session hijacking is another security violation method. So here it is intercepted already, which is the already established session is intercepted and it is attempted to bypass the authentication. So how this occurs, which we'll be able to understand easily with the help of a diagram. So this is how the normal say a standard security attacks take place, the normal conversation between the sender and the receiver is shown here. That is, at the start, the sender will be sending data to the receiver, and receiver might either send back the data or not, depends on the receiver. Normally, the sender and receiver will be exchanging messages among them. What happens in case of masquerading here is the attacker will be observing this conversation happening, and as we have seen, next it will hijack the session and it will try to pretend himself to be an authorized user. So what happens now here? The receiver thinks is that it will hijack the session. The masquerade attacker will hijack the session and start the communication with the receiver. Now the receiver here actually thinks that he is actually talking with the sender and not actually talking with the sender, whereas in principle he is actually talking with the attacker and exchanging valuable information. Then in the man in the middle attack, what happens is the attacker will just be listening to the communication happening between the sender and the receiver, and then jump in between. What he will do is he will pretend that he is the receiver as well as the sender. In this scenario, the sender will send a message to the attacker, and the attacker will communicate that message to the receiver, and vice versa. So what will happen is the sender will send the message to the attacker. The attacker might modify this message and send it to the receiver in order to gain more information. Same thing happens in the reverse order. That is, whenever the as the modified message is received by the receiver will send other data than what he would have supposed send if the sender was actually sending the message. So the attacker will gain more access to this, and he will again modify this message and communicate back to the sender. In this way, the attacker will get much more access to the sender as well as the receiver. So as there are security attacks, there are various security measure levels also. So it is absolutely impossible to maintain complete security, but it is possible to make the cost to the perpetrator sufficiently high to deter most of the intruders. Now the security must occur at 4 levels generally to be more effective. So it can occur at the physical level, that means actually physically at the places where the modification might occur or the attacker might be present. This can be data servers or connected terminals and other servers. Then the another level could be human, that is the humans themselves causing a problem. So social engineering needs to be avoided. Also, the humans need to avoid phishing and dumpster diving. Then the operating system again needs can take care more about security. So protection mechanisms are used by the OS as well as debugging is used by the OS. Then in the network, intercepted communications, interruption, and denial of service can occur, and it has to be maintained or checked that these don't occur. Now, security you can define it as as weak as the weakest link in the chain. But whenever there is too much security, whether that would cause a problem to already successfully executing process, that needs to be determined. So a trade-off has to be made in that scenario. Now there are various program threats. There are whenever we talk about program threats, there are many variations and hence there are different names. So first one is a Trojan horse. So it's a code segment that misuses its environment and exploits the mechanism for allowing programs written by the users to be executed by some other users, which they are not having access to. So some of them could be spyware, pop-up browser windows, and covert channels. These come under Trojan horse. Generally, up to 80% of the spam delivered by the spyware infected systems is generally a Trojan horse. Next is the trapdoor. So specific user identifier or password circumvents normal security procedures. So this is done with a specific purpose. So it even could be included as part of a compiler. Now the difficult part is how to detect them. Now other type of program threats will be logic bomb. So it's a program that initiates a security incident under certain circumstances. Now another program threat could in fact be stack and buffer overflow. Now this exploits a bug in the program. The overflow either due to the stack or the memory buffers. Now whenever a program is returned, the problem might be that the program is not written at a very proper manner. So the failure to check the bounds on inputs or arguments might be one of the scenarios. Now, what will happen is the pass arguments on the stack are returned into the address of the stack. When the routine returns from the call, it will the attacker will exploit this, and whenever the routine returns from the call, it will actually return to a hacked address and not to the actual address where it should return back. So that is why the unauthorized user or privilege escalation can happen by usage of the by using this program thread by unauthorized user. This is a fragment of the C program which is used with the buffer overflow condition, and which can be used by the attacker, and it can exploit this problem which is there in the program. Now this is the layout of a typical stack frame which most of us already know. There is a return address which is placed on the stack, then there is a saved frame pointer. There are some variables which are automatically present on the stack as they are pushed onto the stack, and certain parameters. Now how can this problems be solved? So the first step for determining the bug is that, and for writing exploit code is that great program is generally required. So the programming needs to be perfect in order to stop some of the attacks, because attackers exploit this problems in the programming themselves to get entry or get unauthorized access to the particular process or program. So script kiddies can run a pre-written exploit code to attack a given system. Attack code can get a shell with the processor's owner's permissions. Now, this could be your open to a network code, then they can delete files, download a program, and many more. Then, depending on the bug, attack can be executed across a network using allowed connections, and in fact, it can bypass firewalls in that scenario. So, buffer overflow can be disabled by stack execution or adding it to the page table to indicate non-executable state. This is one way of taking care of the program threats. This is generally available in Sparks and x86 systems, but still they have some security exploits. Another program threat which we have not talked about is virus. So there are viruses. Viruses is a code. Virus in fact is a code segment or code fragment embedded in a legitimate program. So a legitimate program contains a virus embedded in it, and whenever it is executed on the system which is free from virus will get infected. A virus is a self-replicating program, and it is designed to infect other computers. It can be very specific to a computer architecture also, operating system and applications. And it is even in fact sent via email or as macro. So Visual Basic macro to reformat a hard drive is shown here. If we continue with the program threads, virus dropper is another one which inserts virus onto the system. Now there are various categories of viruses, and it will be thousands of viruses. It can be file parasitic, then boot memory, the macro, source code, polymorphic, generate to avoid having a virus signature, encrypted. It could be stealth, tunneling, multi-partite, and armored. And the threat still continues. Attacks are still common and they are still occurring, even though security is best provided by the West. Attacks have in fact moved over time from science experiments to tools of organized crime. Now, what do you mean by organized crime? In organized crime, the specific companies are targeted. So generally, what happens is sometimes botnets are created to use the tool for spam and DDoS delivery. And a keystore logger is generally sometimes used to grab passwords and as well as credit card numbers. But the question is, why is Windows the target for most of the attacks, and not the open source operating systems maybe like Linux? As you can see, the viruses or program threats are generally less common in Linux systems compared to Windows systems. Why is that? The main reason for that is Windows is the most widely used operating system by most of the users, so it's most common. And the main problem here is everyone is an administrator. So licensing is generally required in case of Windows, which might or might not be present. Next, we come to the system and network threats. Some systems are open rather than secure by default. So this reduce the attack surface has to be reduced, but it's harder to use. More knowledge is needed to administer them. Network threats generally are harder to detect as well as prevent. So protection systems are weaker in this scenario. It's more difficult to have a shared secret on which to base the access. No physical limits are present once the system is attached to the internet. So that is why it is very difficult to determine and detect this type of threats. Even determining a location of a connecting system is very difficult because the only knowledge in this scenario will be the IP address. So based on that, it is very difficult to determine what is the connecting system which causes the attack. Next time of system and network threat is a worm. So it uses a spawn mechanism and it's a standalone program. Now, what is the internet worm? The internet worm exploited Unix networking features and bugs in finger and sendmail programs. It exploited a trust relationship mechanism used by the R shell to access friendly systems without usage of a password. So a grappling hook was one important program uploaded main worm program. So a grappling hook program was used to upload a main worm program. It consisted of 99 lines of code, C code. A hook systems then uploaded main code, tried to attack connected systems. They also tried to attack or break into other user accounts on local system via password guessing. If target system is already infected, then really it is aborted except for every seventh attack. So this is just the illustration of how a Morris internet worm will work. So worm will be set to the target system. Then the grappling hook program, whenever it executes, it will request send a request to the worm, and worm will send the data or the attack over the mail. Then there is a finger attack again, and finally the R shell is attacked. Then the network threats can also happen through port scanning. So this is automated attempt to connect to a range of ports on one or a range of IP addresses. Detection of answering service protocol is also done. Detection is also done of OS and which version is running on the particular system. Nmap is something that scans all ports in a given IP range for a response. And Nessus has a database of protocols and bugs and exploits to them to apply against the system. And this is frequently launched from zombie systems. This decreases the tracing ability in that scenario. Then you have the denial of service. The denial of service is a very common attack which takes place most of the time. This is this overloads the targeted computer, preventing it from doing any useful work. So there is also DDoS, which is a distributed denial of service, and is come from multiple sites at once. You can just consider the start of IP connection handshake. So how many started connections can the OS handle? That is one more important question. Consider traffic to websites, for example. Now here, how can you tell the difference between being a target and being really popular? This can be accidental. So CS students may be writing bad fork command or fork code. As you know, fork will create a process, or it could be purposeful, which can be done for extortion and punishment also. Now, cryptography is one more important tool which is used from security point of view. So it's the broadest security tool available. Its internet to given computer source and destination of messages can be known and protected. This OS creates, manages, protects process IDs and communication ports. Source and destination of messages on network cannot be trusted without cryptography. So local network will generally have IP addresses. Consider unauthorized host added. How it can be prevented from happening. The wireless wide area network or internet. Then how do we establish authenticity in this scenario? It cannot be done via IP address. So cryptography is essential tool which is used to provide security in case of systems. It's a means to constrain potential senders, that is sources, and or the receivers, which are destination of messages. Cryptography is generally based on secrets. That is, there are keys present. So there is a key which a source sends from the source to destination, and at destination the key is again used to decrypt the message. So there is encryption occurring from the sender to the receiver when the message goes, and at the receiver end, once the message is received using the same key, the decryption of the message is occurring, due to which the messages are sent, and whenever they are sent, there will not be erroneous. In case erroneous, that also can be identified with the help of cryptography. So cryptography enables confirmation of source when the receipt not received only by a certain destination, and the trust relationship between the sender and the receiver. So this is how cryptography will be helpful in providing security to the computer systems. So what we have seen in this lecture is the various security threats which can arise, why security is necessary, the various types and classifications of security. Then there are various mechanisms which were present, and how cryptography can be used as a tool to stop this security threats from arising. Thank you.